Okay, so let's take a look at those last two problems on the 2.6 packet that did not make it into the first video. I try to keep these a little bit shorter so we can pay a little better attention to the different details. So in question number 4, which is the first one I'd like to look at, I'd like you to notice that number 1, we have a second degree divided by a first degree equation, which is going to yield a first degree answer. So in this little gap up here, I'm going to go ahead and take negative 2/3 and divide it into the little quadratic that I was provided. Negative 2/3 times that is going to be negative 8/3. Then when I add down, I'm going to get negative 11/3. Now, keep in mind, I'm not dividing by a normal problem, but that 3 is going to cause trouble for me. And so instead of calling this 4x minus 11/3, it's going to become y equals 4/3 x, because I had to divide by 3, minus 11/9. And that's going to be the equation of that slanted asymptote. So negative 11/9 is negative 1 2/9. So it's just a tiny little bit below there. Of course, it has a slope of 4/3. So if I went up 1, 2, 3, 4, and over 1, 2, 3, and notice it's just going to be just a little teeny bit below that value. So this looks like a nice little equation of my slanted asymptote. I have a nice vertical asymptote at x equals negative 2/3, which is going to be right in here. Now, I personally really like it if all asymptotes are labeled thoroughly. It just makes us look professional. Now, the rest of the story is a little bit technical, but of course, because the graph is getting close to this, as x goes to infinity, this one goes up, which means the graph itself is going to go up along with it. Since 4/3 x minus 11/9 is going down to the left, the graph is going to follow it down. Now, what I have to figure out is what is happening to the left and the right of those negative 2/3 values. So hopefully you can just kind of believe me on this, but when I plugged in a number that is very, very close to 2/3 up top, I got a positive number. Just if you believe me on that, that would be super helpful. 2/3 squared is 4/9, times 4 is 16/9. Add another 2/3 because it double negative. It works. But in both cases, whether I'm a little above 2/3 or a little below 2/3, we still get a positive answer coming out of the numerator. But if I go a little bit below 2/3, this one was negative, and this one was positive when I was a little above. So this one went to negative infinity and positive infinity. Well, if you put that together, this negative infinity that I see out of this one on the left side means the graph is going to go down here. This positive that's sitting here on this one, on the right side, means the graph is going to go up. Well, the last little thing that I thought would be helpful is two more little things. One, if we plugged in 0 for x, look what you'd get on top, is you'd just get negative 2. So I'm just going to plug in 0 for x. I got negative 2 on top and positive 2 on the bottom. I got negative 1. Well, that's crazy. Look how close to the x-axis that is. It's right here. I mean, that's almost touching the curve. So the only way it can go through this, and that is if it somehow swooshes down really, really low, gets very, very close. And these graphs tend to be symmetric, which means if it's going to get this close to the point of intersection of these two, it's going to do the same thing in here. So it's going to get very, very close to that point of where those two asymptotes together and turn the corner. If you graph this, you're going to find that it's remarkably similar to this graph. And then question number 5. Hard enough, so I didn't give a leading coefficient, but if I have a third degree divided by a first degree, I do get, in fact, a second degree. And my coefficients are 1x cubed, no x squareds, no x's with a minus 4. I'm going to divide that by x minus 2, so remember we put our root. So we're going to go through the process. And remember, I'm not going to even bother with this. Now, this means that my end behavior asymptote is this one. And I do know that some of us are really, really good at graphing these things. Some of us are not as good. I personally chose to get it into vertex form because in vertex form, I then can pretty easily make a nice looking graph. Remember, we took the two we cut it in half and squared it, but then we had to balance that by adding one and taking one away, which means I can go to the vertex of -1, 3, and then I could use the 1, 3, 5 pattern. So here is -1, 3, and I'm going to use the 1, 3, 5. Let's see, 5, and I'm just going to go to 7 because 2, 4, 6, 7. I think that's pretty good, and right there. So this is going to be my end behavior asymptote coming in like this. That's not where the graph is, but that's what the graph wants to look like. I also know that it gets very, very close to x equals 2. So I've got a vertical asymptote at x equals 2. And of course, this is my end behavior asymptote right there, y equals x plus 1 squared, and with a plus 3, my little thing right there. Now, if we go ahead and look at what happened to p as I approach the number 2 from both the left and the right, well, you know, it's fairly simple because a number that's close to 2 cubed is pretty close to 8 minus 4 is clearly positive. No matter what, if I'm around the number 2, that numerator is positive. But if I go above it, I get a positive. If I go below that 2, I get a negative. Again, 2.1 would be positive. 1.99 would be negative. So it's going up on one side. This going up matches with this asymptote. And going down on this one is going to match the other asymptote. And a little bit tricky here, and I chose not to do this in the live class, but we really, really should. The reality is, if you plug in 0 for x, you get -4 on top and -2 on the bottom, so you get 2. So it hits right there on the x-axis. And then the other thing is if we look for where the numerator goes to 0, it actually happened at the cube root of 4, which is right in there. So if we play connect the dots, the graph is going to swing in this way, but now it has to get very, very close to that parabola. And what you'll find out is it's so close to that parabola that they almost touch. I mean, you really looks like it's almost touching. Then the last thing is we know it's going to get close to this asymptote here and this one. That's the part it sometimes takes a little practice to figure out. If we took the time, we could plot in maybe one more point, like where is the graph really at 3? And that wouldn't be too hard to do because 3 cubed is 27. 27 minus 4 is 23. 3 minus 2 is 1. So right in here at 3, we got a height of 23 right in here. But that does give me something because that meant it dropped all the way down to there and rips right back up like that. And now we don't have a kind of a good graph. We have a phenomenally good graph. And that kind of finishes our 2.6 notes. Hopefully that was helpful. Let me know if you need any more help. More than happy to discuss stuff with you. You have a great day. Howdy. Boy, it's going to be interesting. We're going to be skinny. We got a bunch of people gone. I'm going to just finish videoing for all of my distance learning people. This video was finding end behavior asymptotes. Not horizontal. Okay, so let's do that. I normally try to, let's copy that link address. Next, public. I try really hard to like video the lessons as they go. But honestly, like when you start like going back and forth. Hey, Mike.
hey, there's no big deal. I'm just
Okay.
gonna say, it takes forever for drywall mud to dry it.
When it's this cold, yeah. Do you have a little space heater you can put in there?
I did throw a little space heater in there. But I did it all day Saturday, and I was hoping it would dry overnight.
Non-linear asymptotes. This is I have so many people in DL right now. I made that list so I could actually keep track of them because those are all Win Life classes, by the way. And I missed somebody on that. I know, and I can't remember who I missed. I'm having to do that now.
Oh, it's crazy. It is. It's crazy.
So
yeah, I was hoping to get at least 2 done